Okay, hello everyone. Welcome back, people of planet Earth. I'm going to do start doing a series of lectures on chemistry, high chemistry as well. And start with bonding and structure as it's a bit more fun than other things as an introductory topic. Just to show you, I don't know whether you can see that. It's not very clear actually, I don't think. The periodic table. The periodic table is, this is chemistry. If you, I want to fold it properly so it's a bit more visible. Okay, so this, if you understand the periodic table and the properties of the various elements going either down columns or across the groups, then you understand chemistry. Okay, we'll go into this in more detail later, but if you understand this, this is chemistry. Okay, the periodic table which Mendeleev invented. I mentioned in an earlier video, seeing these names of these famous scientists like Mendeleev and Bohr made it more interesting, made it more human. I think it made it more interesting, but yeah, I'll come to that shortly. So the bonding and structure. The atoms are arranged in across rows and down groups, okay? And they all they have properties. As I said, in high grade chemistry, you're expected to know your Nat5, okay? You should understand this completely. So as you go along the periodic table, I could actually grab this one. This is clearer, I think. As you move along from hydrogen to, that's helium, this is a bit old and faded, but there's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, okay? Chlorine. Nitrogen, then sodium, magnesium, aluminium, silicon, phosphorus. Each time you move along, then the atomic number goes up by 1. So it's atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Atomic number 11, 12, 13, 14, 15. So each, as you move along, the number of protons goes up by 1 each time, okay? Number of neutrons doesn't go up quite the same way, but number of protons rises. And the atomic number is equal to number of protons. And the number of protons equals number of electrons, okay? And as you go down the column, or as you go down the column, this here is got 1 shell, okay? Row 2 has 2 shells. You got the inner shell and the second shell. Row 3 is 3 shells. Row 4 is 4 shells, 5 shells, 6 shells, 7 shells. So as you move down the column, the number of shells rises. So the outermost electrons get further and further away from the nucleus, okay? As you move along the rows, the number of shells is not increasing, but the number of electrons is increasing in the outer shell, okay? So the second shell is 2 electrons, sorry, the first shell is 2 electrons, but the second shell can have up to 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, when it gets to neon, it's completely full outer shell. Okay, same with this one. 2 in the first shell, and then 8 in the second shell, and the third one can have up to 18. Okay. So, yeah, that's the periodic table. So you should know your Nat5 inside out. So to start this, basic bonding theory, I will start first of all looking at these elements here, which are the metals, things like titanium, chromium, manganese, iron, cobalt, nickel, gold, mercury. That's silver, that's gold, okay? That's lead. Pb's lead. That's palladium. Where's lead? That's lead, okay? I'll look at these first of all, okay? You got copper, okay? So, metals, okay? And metallic bonding, okay? So, in metallic bonding, the basic structure you need to know is this, okay? So you've got lots of positive ions with, I'll draw these are electrons, okay? Pen's a bit thick, but you get the idea hopefully. Pen is a bit thick for this, but hopefully you'll get an idea of what's going on. So you got these are positive ions, okay? And these are delocalized. It's too thick, this pen, it's not coming out. These are delocalized, delocalized electrons, okay? I'll try to get a thinner pen so I can write more clearly. But in metallic bonding, you got all these positive ions held together by a sea of delocalized electrons, okay? So when you take something like iron, which is extremely difficult if you know your iron gate, you can't bend it because these are all basically held very tightly together, okay? But then something like aluminium or copper wire, which you can bend, it's very easy to shear these across, so you can very easily pull them like this. So you can alter the structure like this. If you see what I'm doing there. So you can bend it very easily, and you got the electrons, the negative charges, okay? So with copper wire and aluminium, which are very flexible, you can easily bend the structure from being like this to bent, whereas because the iron's not held together so strongly, I write these as +1 charge, but some metals actually have 2+ charges, some even 3+, but it's just diagrammatic. It's just diagrammatic. So yeah, these are all positive ions. So this is basically metallic bonding, okay? In covalent bonding, okay, you have the electrons, you have a sharing of the electrons between two atoms. The electrons are sharing of the electrons, okay? between two atoms. Okay, so for example, if you have two carbon atoms, you got, well, I suppose a simple example is a hydrogen. Maybe start with a hydrogen circle plus, okay? Plus. And then you got negative, how do I write this? Okay, so you got the two protons in the nuclei and sharing electrons, okay? So this is hydrogen, H2, okay? Gas. So you got two electrons shared, okay? When you there's always two electrons shared in one bond, so you would write this as like this, okay? The single line there, this represents the two shared electrons, okay? Okay, so that's clear. Carbon 6, so it's 2, 4 on the outside. So you got carbon, you got 1, 2, 3, 4, and then you got draw these as circles to represent them differently, okay? And then you got plus in the middle. It's actually times 6 because it's carbon, so this is carbon, carbon like that, okay? So you got the second shell, outer shell, has 4 electrons, and there's 2 in the inner shell, which are not shown in the diagram, but again, the 2 electrons are shared, okay? And they're equally distant from the nucleus. The electrons are from the nucleus. Okay? So you got these covalent bonds, you got there are other molecular forces. I'll go into, with the covalent bonding, you also get molecular molecules forming as well. You get covalent molecular elements. Covalent molecular okay, so examples include, well, I've shown you carbon-carbon. You got nitrogen molecules do that again. Nitrogen is a triple bond, okay? You've also got phosphorus, the element phosphorus, which forms okay. This is called P4, okay, and that's N2 gas, okay. So what I'm doing is I'm showing you various structures that can form with when atoms come together by covalent bonding, and they can form various molecules. in this case nitrogen to gas, P4, which is phosphorus. You got 4 phosphorus atoms joined by covalent bonds. Okay. You've also got the element S, which is okay, which sulfur is below oxygen, same row as same column as oxygen. Okay, the same column as oxygen. Sulfur can form S8. Okay, so you got a compound a bit like this. You get sulfur can form 1, 2, 3, 4, 5, 6, 7, 8, okay? 1, 2, 3, 4, 5, 6, 7, 8. So that's sort of the structure of a molecule of sulfur, okay? S8. Nitrogen has... I'll show nitrogen quickly works as a covalent molecule. So you got nitrogen, okay? So you got the 2 inner electrons, and then you got 3 outer electrons, which is 5 in total. Sorry, atomic number 7, not 5. So you got basically works. You have 4. When it says 5, I was thinking the 5 outer electrons, the 7 in total. Okay, so you got 2 nitrogen atoms like this. I'm drawing them as circles just to make them so they're clearly distinct. Okay, I'm drawing these are, I'm illustrating electrons as crosses and circles to make them clearly different. So when these come together to form a covalent molecule, okay, these 3 electrons overlap, so you get like that, and you get, so this is nitrogen, which is a triple bond, okay, like that, and you got the 2 pairs of unpaired electrons, okay, so of unpaired electrons. So yeah, this is slightly growing to Nat5 still, but it's it's Nat5 stroke high grade. I'm showing you how the electrons are shared in covalent bonding. So this is a covalent bond. This knowledge is above Nat5. It's high grade. Okay. And there's also oxygen I can represent as well. I think I'll call it quits and pick this up next video. Okay. And we'll take it from the next video. Okay, hope that's clear for you, and ask me any questions if you have any, and yeah, subscribe, help my channel. Thank you.